Okay, so the final thing I want you to try out is you have this in the Google form, but what I want you to think about is how much tension, or not think about even, go ahead, go further than just thinking about it and actually solve it. But how much tension is in that rope when the person is doing the hammer throw? So when they're doing it, I looked it up, the Olympic designated mass for one of these hammers is 7.26 kilograms. So they're pretty hefty, got a lot of mass to it. The length of the string has to be 1.213 meters. I estimated the length of the guy's arm at about 0.9 meters. I figured he's kind of a tall person probably if he's doing this. I looked it up, the average arm span was like 0.8 meters for an adult man. And then I was like, okay, I'm just gonna add 0.1 meters to it because this guy's probably tall. The distance that he throws it, so the distance that this thing moves, in the X direction is 78.68 meters. That was from the little blurb at the bottom that said, hey, he won the gold with a distance of 78.68 meters. For the Y naught, the initial height that he's throwing it from, I kind of estimated it, saying that it's 2 meters. Looks like about his full height, so like 6 feet plus his arms. So I just called it about 2 meters. The launch angle, I just kind of stacked a few frames on top of themselves like I like doing, and traced it out, and then I measured it with the ruler and said, okay, the protractor function of the ruler that's in OneNote, and I said, okay, well, it looks like about 47 degrees. So it looks like it launches at an angle of 47 degrees, and then we're going to say that the speed that he was spinning it at, so the speed that it was spinning at, is the same as the initial launch velocity. So using that information, I want you to figure out and calculate how much tension was there in that rope, in that hammer, when he was spinning it. So you're going to figure that out. I'll kind of walk you through that in the key really quickly, but this is just kind of me introing it. After that, I have a few more questions, just kind of thinking about, hey, if we change this situation, what would happen? So this is kind of like qualitative going to quantitative a little bit to some degree. So if the radius was doubled, how would the tension change? If the speed was doubled, how would the tension change? If the mass was doubled, how would the tension change? Then the last little bit, this one's a little bit more involved, but let's say the radius is the same, the mass is the same, the new tension is half of the original value. How will the new distance that it travels, let's call it x new, of the hammer travels, how will that compare to the initial launch distance, x naught, to that 76.68? Yeah, 78.68 meters. So how will the new distance, if the tension is cut in half, how will it compare? Will it be less than half of the original value, greater than half the original value, but less than the full original value? Or will it be greater than the original value? And I want you to explain that. So this is all in the Google form. I just kind of wanted to preface it really quick. And yeah, all right, cool. Have fun with that.